Hello, everyone. Thank you for making it. I know this is late on Thursday, but really appreciate you guys being here. My name is Andrei Eftimov. I'm a cloud consultant with the Google Cloud Professional Services team. And I know you've had the opportunity to go to many sessions. So like the airlines say when they have you safely seated in their seats and buckled up, thanks for choosing us. I've actually had the privilege to work with a number of customers and in various different industries on a number of projects related to machine learning and big data. So trust me when I say that the folks coming up next are going to be a treat for you. We've worked with the Home Depot team on a project that's near and dear to many retailers that I've spoken with. So without further ado, let me introduce you to Pat and Sashi, who've spent many cycles trying to solve that problem. Please welcome Pat and Sashi.
Thanks, Andre. All right. Thanks, Andre, for such a gracious introduction. Hope you guys are having a great conference. We certainly are. And thank you for coming to our session. So the agenda for today is we are going to talk about an interesting use case that we've been working on in Home Depot for solving a classic retail problem. So we're going to lay out what the problem is, what the business context is, and then talk about what the possible solutions we had, which one we picked, and kind of do the technical challenges and lessons learned kind of thing. So again, my name is Sashi Gandavarpu. I'm a data scientist on the Home Depot team. With that, I'll hand over to Pat, let him introduce and kick it off.
Thanks, Sashi. Again, my name is Pat Wu-Wong. I'm a principal developer for Home Depot. I've been there for about almost 9 years now. So I have a lot of experience with like how Home Depot works and all of the changes that it's gone through. So it's really exciting to be here presenting like the work that we've done. So I'll give you a little bit of an intro of what Home Depot, kind of like the scale of Home Depot, right? So we're the #1 retailer, home improvement retailer in the world. We have about $100 billion in annual revenue. 2,200 stores across the US, Canada, and Mexico. And each store has about 100,000 square feet of space per store. And we have about 400,000 associates across the entire corporate landscape. And the big important one here is to know that there's 33,000 SKUs in each store. So kind of like framing up like the scale of what kind of problem we're trying to work on right now.
Yeah, and one of our guiding strategic principles for our talk here is what our CEO, Craig, who's up there, kind of drills into us every single time there is an investor conference or a speech, that we strongly believe customer service in our stores starts with the product being in stock and on the shelf. And the key phrase for our talk today is the on-the-shelf piece. So we want to kind of dig deeper into what that means for Home Depot and what the opportunity we found and how we are going to tackle that.
So going straight into the problem. So one of the things I'm sure like all of you guys in the room have had this experience before, right? So you may have checked like the website. If you're trying to buy something, you go and see that there's like 4 items in stock, whatever store it is. And you're like, okay, well, that means there's a bunch of them there, so I can go to the store and hopefully get the thing that I want, right? Well, you go into the store and you walk to the shelf where it's supposed to be, and it's not there, and you're like, okay, well, what am I going to do now? Who am I going to find the thing that I want? Especially in like a Home Depot, you probably won't even see an associate like anywhere nearby when you're trying to walk and find or have them help you find something, right? So you probably, if you really don't know where to go and you've never really been in a Home Depot before, you might give up. More than likely, you're going to give up. So one of the things that is really important for understanding on this slide is you have to remember that a store associate does not really think of in stock as just what's available on the shelf. A Home Depot it's like a working warehouse. So when you go in, really the stock is like anywhere that goes from on the shelf all the way into the overheads. There's no back room, right? So there's nowhere for anything to be other than somewhere on the shelf. So if it says there's 4 things in there, there's probably 4 things in there somewhere. Someone probably just moved it. And one other thing I want to mention is that when you don't see it in the store, it's not necessarily that it's out of stock, right? So that's another key point, is that it's actually just off the shelf somewhere. So it could just be anywhere within the store.
Yeah, some examples of shelf outs on the 3 sections we have. The lighting, you could see on the bottom bottom part of the bay, there is a hole there. Again, as Pat said, that may mean shelf out or that may mean stock out. That would depend on how much our databases are saying we hold in the store. But that's how it would look like. Cleaning section, the example I have is a little bit interesting. As Pat said, shelf out may not necessarily mean that we don't have stock on the shelf. It could be that another product is in front of the actual product, or it's like products just misplaced on the ground everywhere. Basically, you could think of it as product not being available for customer to pick up when they come into the store. So that's what we are defining shelf out as. And garden is another example here. Another thing to note is Home Depot is highly seasonal business, so shelf outs are correlated with sales. During spring, you'd have more shelf outs in garden. During other seasons, it's going to vary a lot with base and departments. So. All right, so how do we measure the problem size, right? So we know there is this problem with shelf outs, but fixing every single shelf out, what does it mean for Home Depot? What's the dollar value of that? So to find that out, we ran a field experiment. What we did was, first the hypothesis is that if we increase shelf availability, that would lead to making the customers happy, and also that would reflect in having higher sales. So to test this hypothesis out, what we did was an experiment where we used a manual brute force approach to make sure that the shelves were always full. Now, we would not have done this throughout the company as a real thing, but just to test it out, what the impact would be, we had a control group and a treatment group where we would kind of employ labor to go in 3 times a day, just get the stuff from anywhere in the store, from the overhead, stock the shelves full, and make sure that the product is available for the customer. And doing that across a period of time, we were able to measure the sales lift.
So what we found from running this experiment was that 1% increase of shelf availability equals a very highly correlated amount of sales opportunity that we can't tell you, but you just you just need to know that it's a really, really big number. So that's the important takeaway from this one.
Yeah.
So why is this a hard problem to solve? So if you guys have ever been in a Home Depot, like for maybe some of you guys have shopped at Lowe's or whatever, it's like the same kind of thing, right? So you go into a hardware store, a home improvement retail store, and the place never really looks like what it looks like in the picture. That picture is really, really pristine. That's like a really, really curated picture for this. So there's always stuff like all over the place. Like you never find what you want. There's screws everywhere. Things are like off the shelf. Sometimes there's stuff all the way. Like it could be in the overhead. Like that. This is actually a really not great picture for why it's hard. So another thing, so there's lots of different teams that are trying to make sure that the shelves are completely stocked. So there aren't just associates that are dedicated to doing the what we call pack downs, right? So you take stuff off the shelves and you bring it down. It's called the pack down. There's the MET team, which is our merchandise execution team. Their only job is to do pack downs, really. So they come in at specific intervals throughout the day to do these pack downs. There's a freight team that comes in at nighttime to do take stuff off the receiving truck and put that onto the shelves. There are also store associates, so those are the people that are wearing the orange aprons that you see all the time while you're in there. And when they aren't helping a customer, their job is to their tasking job is to make sure that stuff is like cleaned up, the the aisles look really nice and all of that stuff. So
Cool. So yeah, as we said, there is X% opportunity in the stores. So and trust us, X is a huge number for Home Depot. So what are the possible solutions we have, right? We could add labor, obviously, as I talked about. And as Pat mentioned, there is already a lot of labor in our stores. We have multiple teams working on it. So sure, adding labor is definitely an option, but that would be what I would call a brute force approach for this. And we would probably have to design new systems or new apps to make sure that's targeted to specifically the shelf out thing and not combined in the pool of labor we already have. But the other techniques that we have looked into, are still looking into, are some of the computer vision techniques that would be either having fixed cameras or robots or drones or all these advanced things that we are seeing more and more deployed in or being POC'd in the stores. So we are definitely working and interested to learn more about those techniques. Sensor fusion is something we've talked to all the big names out there to try to see what technology is ready, available for being deployed in a Home Depot store. Again, remember 2,000 stores and 100,000 square feet per an average store. So we want to get into that with solid proof of concepts. But for now, what could we do that can solve this problem, at least get the chunk of that X%, right? So that's where I would say enter machine learning. So yeah, we started gathering data for this. What we started with was a pilot called OSA, basically on-shelf availability. We employed a slightly manual approach to understand what the current shelf outs are. Meaning we sampled a set of stores from our Home Depot that is representative of the overall stores, and said whenever the Met team is going to go and do the general service, and which is basically packing down the aisle and making sure everything's looking good, we wanted them to scan the hole that they see in the shelf using a scanner app, which for the whole bay would probably takes around a minute or so for them to just scan all the holes. And they're going to do that for each bay once in 2 weeks. So by doing that, we would know what is currently shelf out in our stores, which we did not have before this pilot started. So this is a manual data collection, but not adding a lot of overhead, because the person that's getting us the data is already there in the bay spending 10 minutes, 15 minutes doing the service. It's just adding a little bit of labeling task for them. And then we did a small proof of concept to see if we could do this, use the data coming out of this, did some pipelining in BigQuery SQL, and generated features. So, and built a training data set. So this is where I'd encourage all of you guys to think about what features would be kind of indicative of anything being not on the shelf, right? In a Home Depot store, and these are not like advanced data collection things like images or sensors. This is just existing EDW data that we have in our warehouse, basically. So on the next slide, I have some of these features that we've been using so far in our model. First of all, the features here are sourced from talking to different domain experts within supply chain, within space planning, finance, within the Home Depot organization. This is where the cross-functional support we've got for building all these features and making sure the data we need is available for us. Also, a shout out to the Google Professional Services team. A couple of guys are in the audience today. So Google sent a few smart guys to help us out with building this model in terms of letting us know what is available in GCP, what kind of tools we can use, and gave us like a really good input into what features we can use, and also built us a POC kind of a system that we could use machine learning with. I'll talk a little bit more about the architecture in a little bit, but for now, features on this slide, right? So I'm going to talk about two features in detail. One is sales and forecast. So for example, if we expect a product to sell, let's say 4 units per week, and we haven't seen any sales in the past couple of weeks. That would be a fairly strong feature, but also less relevant because we've already missed the signal for 2 weeks. We can detect the shelf out in a case where we have on-hands in the store, but we are not seeing the sales. So that's your classic slow-moving item kind of category. The second thing I want to point out, which is more specific to Home Depot and retailers, is this play that happens in a store between the pack size, the shelf capacity, the on-hands that we have at any particular time. So let's say we ship, we source a product in packs of, say, 8 units. And so the night before, if we receive 8 units, but the shelf that we have, the shelf capacity for that product on the shelf is only 6 units, then you're going to put 6 units on the shelf and put the remaining 2 in the box and tape it back up and put it in the overhead. Sometimes label it or you don't label it. This is something that all of us had to do when we had store days. Like this is close to our hearts, right? So then when you're putting that, you know that only the person who's putting it there knows that there are 2 units in that box. And if you're really doing your with due diligence, you'd probably write it down with a pen what the stock number is. In other words, we don't have a tracking of where the product is in the store. So then if we, in that example, if we sell through 6 units, then that product is ripe for being a shelf out because we exhausted the shelf capacity by knowing the sales since the time received with the pack size of 8 and the shelf capacity of 6. So all these factors play a role in determining how many are on each shelf. And there are other factors, other features that we are using in the model that I have here. Another slide for all the data scientists in the room. This is, again, to talk about the algorithm details. This is a classic binary classification model. We are trying to model whether a particular product is on the shelf or not. So this is a yes or no kind of a variable. We have 2 systems in which we have deployed, we have ways to deploy this model. The one that's running in production today is using Scikit's implementation of XGBoost running on a Google Kubernetes engine. We use this setup for both training and inference. We do a weekly training of our models to, as I said, to make sure the model is fresh because of the seasonality aspect of this. And we do an inference pipeline every day. So we can use the predictions of this from this model and send it to the store and act on it. We have another model with TensorFlow running on ML Engine. That's something we hope to deploy soon and do evaluate both the models in different set of stores. With regard to the charts I have there, on the top right is the feature importance. This is just a sample graph that shows while we are building the model, we constantly kept track of what features were more important for the model. So you can kind of keep track of what the model is doing. This is one of the reasons why we like decision trees, so that the features in there are a bit more intuitive for us, especially when we are doing the version 1 of the model. On the bottom left, I'm going to spend a couple minutes talking about the PR curve here. So this is the classic trade-off for any machine learning system, right? What is the cost of a false positive versus a cost of not sending an actual shelf out? So on the y-axis is that precision of the predictions that we are generating, and on the x-axis is how much of the shelf outs we are capturing. And to illustrate that, I have a couple of points on the graph here, a red star versus a blue star, where the red star is basically a point where we are getting a higher accuracy of our predictions, but we only catch smaller number of shelf outs. So the cost, and this is again a sample PR curve, the point I wanted to make is the cost of sending a false positive is basically sending a task to the store associate, asking them to go to that particular bay and find that product in the overhead and fix it, right? So if it is not a shelf out, we are basically wasting the associate time. On the other hand, not sending a true shelf out, and let's say in this case, if it's like a power drill, that's $200, not having that ready for that contractor that's going to walk in is the last sale of $200. And they, especially our pro customers, right? They are on the clock. They are the ones that would not be waiting for a store associate to go get a ladder and get the product down. So that's the two that's the trade-off that we had to manage. The other aspect here is we are trying to generate predictions and deploy it to a store and get adoption rate from the store associates to go fix the things that we are sending. So we knowingly cannot send a list that's like 30% or 20% accurate, even though that's going to make up for the lost sales, right? So we want to get as much adoption from them as possible, so that the list we are sending is actionable. So today, the first model that we have live in the stores is more towards the conservative side of precision. So we are okay sacrificing fixing few shelf outs, but we want to get maximum adoption from the field. So we are more leaning towards the red star over there in terms of actionability.
So one of the things that we did after we had built this original model was before we even set up all of the data pipelines, before we built it all out in Google Cloud, we ran it locally on our laptops, right? So we just pulled in a bunch of data from BigQuery. We pulled it into our laptops and ran this stuff in like Jupyter notebooks, right? And we had a model and we wanted to do some inference and kind of like validate that what we were doing was the right thing to do. So we printed out a list of all of the tasks or all of the potential shelf outs that we had, and we went to the store and just checked them off to see how well it was doing, to see if it was actually going to work. And what we found was it was going to work. So obviously we're here. So yeah, we were actually very, very surprised of how well it worked, right? So we started going down the list, and we're like, oh wow, this was right, this is right, this is right, this is right. Okay.
I was not surprised. But
I was. So yeah, so after that happened, we were like, okay, we got to go back to the drawing board and like start really building this full thing out and starting to try and productionalize it, right? So we had to build all of this other stuff to make this happen, right? So let's see. So obviously, right, so we had pulled all of this data from BigQuery, right? And I said we were running it in Jupyter Notebooks. We ended up building a bunch of ETL steps inside of BigQuery and running the ETL transactions straight on BigQuery. Initially, we had been doing some of them in pandas and things like that, right? We had to automate the training pipeline. So the training pipeline was, again, in a Jupyter notebook running XGBoost. So we had to find a way to take that code and turn it into like a little what would you call it? Like a little small runtime to run the model in a ad hoc type of way. So we created a thing in Kubernetes that allowed us to run this model on demand when we wanted to for our training and inference pipelines. And then we also, so another thing that we haven't really talked about yet is how we were planning to get all of these tasks to store associates. So we had an application that already existed in the stores, and this application is called Smart List. This is an application that's at the SKU level, which was basically perfect for what we wanted to do, right? So we wanted to send out tasks for individual SKUs. We wanted them to go fix individual things, like very, very targeted tasks, and we needed a way to obviously get that to them. So this application already existed in all of the stores, and it existed already in all the associates' hands. They're familiar with using it. They were comfortable using it. So there was no additional step to retrain them. So what we ended up doing was we took our model and we injected tasks into Smart List with a slight modification, right? So that thing that you can see right there with that shelf out yes or no is something that we introduced as part of this project. We established like a feedback loop so we could tell if things were actually shelved out. So if you remember from earlier in the presentation, we had this manual data collection step for gathering our training data, which we had the MET team scanning all of those different things, right? So we had them scanning all of these different things, and that's what we used to build our original model. So our intent later is to just use this shelf-out data that's coming back from SmartList to retire that program. Hopefully we can at some point, because obviously it's like added labor in the stores, and we have this continuously running, so we don't want to have to continue supporting taking that additional labor and having them have to do the scans, because over time it ends up being a lot for however many stores it's in. So, all right, let's see that. I'm going to walk you through the architecture of how it's set up. So, first, on the left-hand side, there's the Home Depot on-premises systems, and then on the right-hand is Google Cloud. So, one of the interesting things about this is that it had to combine the hybrid cloud model, right? So, I mean, you guys keep hearing that throughout the conference, right? So, this is definitely a hybrid system. So, we couldn't have been able to do this all in the cloud, nor could we have been able to do this all on premises, because a lot of the technologies that we use to build this, the inference, the training pipelines, and whatnot, didn't exist on Home Depot before. So, if you look at here, so right, all of our data is sitting in BigQuery. If you listened to, or if you attended the talk that we had, Home Depot had another talk about our EDW migration from our on-prem systems to BigQuery. That was a huge enabler of this project. So all of our data is in BigQuery as our EDW system, and what we do there is we have the SQL preprocessing steps that export the data to GCS, Google Cloud Storage, and we have our data pipeline, which is a part of the tooling that was built around doing the data migration from on-prem to BigQuery. And the data pipeline is the thing that's orchestrating all of these steps for us at the moment. So every day we're running our inference pipeline at 6 a.m. So one other interesting thing to remember about this whole setup is that we're building a production system off of analytics data. So data that could or could not be in the cloud at the right time. So if you think of how all of these different data systems are flowing into the cloud, right? So you have supply chain data, sales data, merchandising data. All of these different data systems have to land in time for us to be able to do our inference every single day at 6 o'clock in the morning. And another interesting thing, or interesting thing is that all of these data domains are owned by different teams. So when something breaks in a different system, we have to go and contact them, and we have to work with them to make sure that the things are landing at the right time, because they all actually land at different times. So some of the ETL jobs are weekly, some of them are daily, some of them are hourly, some of them are streamed in. It was interesting, like bringing all of those different types of data systems and input features together. Next, we have our retraining. So this, Sashi mentioned this earlier, right? So we have a retraining that happens every week to account for seasonality, which means like things that could happen between the last, like, so if for the non-retail people that are in the room, seasonality is something that, like, you have products that only sell during certain times of the year, right? So Christmas things, right, are a really good example. We only sell Christmas trees during Christmas. So it doesn't make sense to include data from 6 months ago when we weren't selling any Christmas things, right? So we continuously retrain our model. Well, not continuously. We retrain it every week to account for these different types of variations within the selling landscape. All of these things, again, run on Kubernetes. So all of this stuff will flow from Kubernetes through our data pipeline back into BigQuery. So after that happens, we push the tasks from BigQuery to our Cloud Foundry on-prem, and then all of that flows through to our store system. So our stores are like mini data centers in of themselves, and then they get them in their phones. So yeah, and then the shell file button is something that we added, right? So I mentioned that earlier, and that goes back through Cloud Foundry back into BigQuery, and then we use that for training and data exploration, so we can see how well our model is doing. We have reports that are generated every day for us to track the rollout, track how our model's performing, how everything is working, like if it is even all working. So what's interesting is that we've as we've been rolling this out, so we had a phased type of rollout, right? So we rolled out to 1 store, then we rolled out to 5 stores. And when we went from 1 to 5 stores, we found out a bunch of things that we had no idea were going to happen. So if you guys remember the first phone app, the Smart List app, right? So when the thing that you guys saw was not the first iteration of that. We had to go through at least 3 or 4 iterations of that, working with the store associates, getting feedback from them, and trying to understand how they were going to use the app. Because we had an extra screen in there that they actually never used, and we didn't find that out until we had all of this data coming back through all of these pipelines to understand that, okay, well, we wrote a screen for no reason, so they don't use it. So.
Cool. Yeah, and Pat was a little bit humble there when he said we rely a lot on other teams' data. What he actually built was a bunch of nicely worded high-pri emails that go out at 7 a.m. and the data is not there.
Yeah.
Do you have caps lock turned on?
Yeah. So yeah. So what Shashi is saying is, if you look at this, the pre-processing step. So when we were doing this so because of these dependencies that we had on all of these different ETL teams, and their data was landing at different times, and it doesn't land at the same time every day. If you look at the jobs that are running, they run in different intervals, different, like sometimes they're an hour late. So we gave ourselves up to from 6 a.m. till 8 a.m. to get these predictions out. And what we built was kind of like a little hackish thing, right? But it waits for the data to land in BigQuery. If it doesn't, it sends a high pri to the team. It sends a high pri to the data owners, and then it ended up being okay because they got one high pri and then they fixed it, and now we're all good. So yeah, Sashi.
Yeah. Also, for those of you who are interested in the timeline for this project, so this has definitely been in work for most of, I would say, the past 1 year. We had different phases of this project going on, starting from the field experiment that I talked about, where we had to do this manual approach to measure the actual dollar value for this. We had to do a pilot model, which again, for Home Depot's, in Home Depot's culture, we have a lot of favorability to do these kinds of POCs. So we were able to actually call the store managers on the floor, set up weekly meetings with them, send them these Google survey forms saying, hey, could you just check this predictions that this model is doing, which is outside their scope of regular work, but they've been really helpful in kind of working along with us to test this model, did these manual validations, and then we had this phase of solidifying the pipelines, building the features, making sure it's hardened, the solution is hardened and running in production. And that's when we started building this app integrating our predictions into an existing app that is going to let us deploy our solution to the stores, and then started rolling out the actual app. And the pilot thereafter app is more like the UI UX cycles in terms of where do we put the button, how many screens we have, what's the adoption rate going to be, and figuring those things out, and then doing a phased rollout. As Pat said, we started with 1 store, went to 5, and today we are in 50 stores, and hope to just continuously monitor this and roll out to the rest of the stores.
So I think I mentioned some of these things already, like the technical challenges that we had while we were deploying this. Obviously, the SLAs were really, really important, right? So I don't think I mentioned this specifically yet. So if when our inference pipelines are running, those predictions are only valid for a very specific amount of time. So if you think about how dynamic the store was, right? So stuff is changing all the time. There's so many teams that are working to keep the shelves stocked, right? So if we send these things in the middle of the day, what is the likelihood that someone didn't already fix it? So if we don't send it by 8 o'clock in the morning, we don't ever send it at all for the rest of the day because we aren't able to generate these inference on an hourly schedule yet, right? Because all of the data doesn't come hourly. Some of it's weekly, some of it's batched daily. So it didn't make sense for us to send anything if it didn't meet our SLA. So we fail if that happens. Another thing that's important is pushing data back from Google to the store environment. It was a little bit challenging because we had to interface with so many different systems. So things that we don't normally code for or that we don't normally work on. So I don't normally work on Cloud Foundry, so I had to learn how to do that. I don't work on store systems really, so we had to figure out how to get the data from Cloud Foundry all the way to the store to the first phone. We had to not rewrite, but add that button into the first phone app. So our team did that as well. And then also building a kind of like a repeatable runtime environment for us to be able to do future projects. So all of these things, that's why it took so long for us to get from point A to point B, was building all of this infrastructure out and understanding how we're going to do projects like this in the future.
Yeah. And on the lessons learned slide, if there's other retailers or other people who want to do things like this, the biggest point that's not on this slide is, but very obvious, is actually having the data in there. Yesterday, from what Pat mentioned, we had a session that covers our journey from on-prem EDW to Google BigQuery. That was a huge enabler for this project, and it's something just unthinkable to do these pipelines on-prem in the previous world. We actually started on the first pilot model was on-prem, so I have like comparison points that the training that would have taken days is now taking hours. Inference that would take hours now takes minutes. So it's definitely the having all the data in there was our biggest first step that was essential for this. And then other things we kind of touched throughout the presentation. Our team in a large organization like Home Depot is greatly benefited by having a well-rounded structure. We had UI UX person, we had software engineers, we had data scientists, and we had all the kinds of skills that needed to do this kind of work end to end, and not really depend on another team that's doing this app to include our stuff in theirs, and then that's going to just delay the whole process. And along the way, we had multiple pilots, multiple buy-ins from the business side of Home Depot who run the store operations. Obviously, they see huge value in fixing shelf outs along with us, and they also wanted to incorporate these smarter, advanced analytics into their apps. So that was a big win, and also using an existing app, not trying to reinvent the whole thing for sticking our predictions in it was also a quick win for us. Again, the operations for something like this needed support from different teams: supply chain, the Met team that would do the general service, the freight team that would do the overnight packing, the store operations, space planning, finance. So everyone over all these teams that I mentioned over the past 1 year that we worked with that we depend on data or execution or different parts of the process. And finally, having a POC culture in Home Depot was definitely the biggest win for us, because this is one of the unique projects that that changes things in the real world as opposed to your digital world. Like having one model and doing an A/B testing on a website is one thing, but having a model sending predictions to the store that you want physical work to be done in the store means that you'd have to convince and present the value of this model along the way. And we were fortunate enough that we had partners in our store operations team to let us build this and deploy this to our stores. And Pat, what would we have done differently?
I think something that it kind of slowed us down was that application integration stage. We really, it basically was a roadblock for us because getting this application out there was something that we needed to have happen. So we probably should have started it a lot earlier than we did. Learning the infrastructure that's required to get all of that stuff out took a while. So I definitely would have started that way earlier. And one thing though is that we couldn't have started it too early because we didn't know if it was going to work. Well, I didn't know if it was going to work. And yeah, so I mean, the timing for everything. I mean, it ended up working. It ended up working out really, really well, right? So I think the timeline kind of like illustrates like how long a project like this will take, and it's definitely a cross-functional challenge. Like where you have to engage all different parts of your business in order to be able to execute something like this, and it's not just one team that can make this happen.
And for a future state, we see three broad workflows for us that we want to focus on. On the model side, I haven't talked about this, but when we have a list of predictions that we are trying to send to the store, you could think of multiple ways of optimizing that list. Obviously, today we want to maximize the precision of that list, but you could think of it as having a weighted loss function in there that would account for sales, margin, and other things like substitutability. Like the example we quote always is, if you walk into a store and try to buy a hammer, let's say we are out of stock on red hammers, but we still have blue hammers, it's probably not the end of the world. You'd pick a blue hammer. So in this case, this is like a substitutable product. So shelf out on highly substitutable products is not very critical. So we want to incorporate things like this, knowledge like this into our model. And the biggest piece that we want to work on is the active learning piece of the manual validation that's happening in the store, telling us if the model is correct or not. So we get that feedback right into BigQuery, and as we are live in more stores, that we are going to get a large sample of that data. We will know where the model is making mistakes, and we can make it better in the future runs. On the data front, we want to we are always on the lookout for finding more advanced data, like the sensors and camera that I talked about. So we are engaged in multiple POCs on that front.
Yeah, and on the ML and AI side, so I mentioned this already, is building this throughout this entire journey. We built a lot of tooling and infrastructure to allow us to do these projects really, really quickly. So we can spin up something really fast. We can try stuff, and it's been a huge huge learning opportunity for all of us. That like me getting to work with Sashi, because I never worked, like I was typically like just an engineer before I joined this team. So learning about how ML works, AI works, and all of the different things that go into building this kind of thing.